Find dy dx by implicit differentiation and evaluate the derivative at the given point. So I'm just going to take the derivative of both sides of this equation. Keep in the back of your mind that I am differentiating by dy dx. That's important because when the variables don't match, I'm going to have to do the chain rule. So for example, well, let me just show you right now. On the left side of the equation, I'm going to have to do the product rule because we've got the y squared, that's one factor, and then we've got the parentheses as a second factor. So the way I do the product rule, I take the derivative of the first factor first, and I leave the second factor alone. So the derivative of the first factor will be 2y. But here's what I'm talking about. Because the variables don't match, I'm differentiating with respect to x, and yet this is a y. So I have to treat y as a self-contained function. So I've basically, by putting the 2 in the front, I've taken the derivative of the outer function, but then now I need to multiply that by the derivative of the inner function, which is y. So I'm going to write dy dx. Okay, it's the chain rule. So now I've taken the derivative of the first factor, and right now I'm going to leave the second factor alone. So I just have x squared plus y squared. And then I put a plus like you do for the product rule. Now I'm going to go through this a second time, but this time I'm going to leave the yellow factor alone. So I'm just going to write y squared, and I'm going to take the derivative of the second factor. So I'm going to have to do one term at a time inside of parentheses here. So the derivative of the derivative of x squared will be 2x. So that's done. Notice that the variables match, so I don't have to keep going. But now I get to the y squared, so I'm going to take the derivative of that. Again, the variables don't match, so I have to do the chain rule. So I do the 2y, okay, that's the outer function, but then I multiply by the derivative of the inner function, which will be dy dx. All right, now I'm moving to the other side of the equation, and I'm just doing the chain rule. So 2 times 2 is 4. And that's it. Okay, so I need to evaluate this at the point 1, 1, and ultimately I need to find the value of dy dx. But I think I'd like to go ahead and substitute 1 for x and 1 for y right now. Feel free to skip this step, but I've just shown my substitution of y, of 1 for every x and for every y. So now I've got 2 times 2. This is just 1 plus 1, so that's 2. So I'm going to have 4 dy dx. All right. I'm ignoring the 1 squared in the front because that's just a 1. Inside the parentheses, I have, and you know what, I don't even need the parentheses anymore. So I have 2 plus 2 dy dx. And this is equal to 4 because of that. The terms that have dy dx in them are now like terms. So I have 4 of these plus 2 of these, so that'll be 6 of these. So I have 6 dy dx. And then I still have this plus 2 is equal to 4. Subtracting 2 from both sides, we have 6 dy dx. Is equal to 2, and dividing both sides by 6, we have dy dx is equal to 2 over 6, which of course is just 1/3. All right, and that is how you do it. Somehow I copied down the wrong directions. My work is still good. We just have an extra step. But first, let me change the directions. So here are the actual directions. Find an equation of the tangent line to the graph at this given point. Whenever they ask us to find an equation of a line, we use point-slope form, which looks like this. And the important thing is that we need two things, a point and the slope. But the great thing is they already gave us the first thing. We have the point of tangency. So we have the point. So all we need is the slope. Keep this point in mind. But that's what the derivative is. dy dx is the slope. All right? Derivative means the slope of a curve at a point. So the slope is 1/3, and the point is 1, 1. So we can just slide down and make the equation. So the final answer should be y minus y, which is 1, is equal to the slope, which is 1/3, times x minus x, which is another 1. So this is the equation of the line tangent to the graph at the point 1, 1. I'm not going to do this for every problem, but let's look at Desmos to sort of check our answer. Let's look and see what this function looks like, and let's see if our line equation really lies tangent to that function at the point 1, 1. So first of all, here's what the equation looks like. It's pretty wild looking, not even a function or anything. And here's the point 1, 1, which hopefully will be the point of tangency. And here's the line that we just found. Notice that it is indeed tangent to the graph at the point 1, 1. Switching gears a little bit here, we need to find the second derivative with respect to x of this equation, which just means we are going to take the derivative twice. Be emotionally prepared. The algebra is going to get very ugly, and there's just no way to avoid that. So here we go. Let's take the derivative of this first term. We're going to use the product rule. So I'm going to look at it as this factor times this factor. So first I will take the derivative of this first factor, which will give me 2x. And I leave the second factor alone. And then I put a plus, and I go back, and the second time through I leave the first factor alone, and I take the derivative of the second factor. The derivative of y is just dy dx. So that's my product rule for that part. So that's over. Okay, now I'm taking the derivative of negative 4x, but that's just negative 4. And the derivative of 5 is 0. So let's go ahead and get dy dx by itself. So I am going to subtract 2xy from both sides, and I'm going to add 4 to both sides. So that will give me x squared dy dx over here by itself is equal to 4 minus 2x, right? I just moved this over there, and I moved this over there. So I'm just going to divide both sides by x squared. So that will give me dy dx is equal to 4 minus 2xy over x squared. So that is the first derivative. Okay, Now, we need to take the derivative again, but we already have this sort of complex expression, so you can see why it's going to get pretty ugly when I take the derivative of this. So I'm going to do the quotient rule. So I'm going to say the second derivative is equal to, and you guys know the quotient rule goes low d high, less high d low. Draw the line, and down below, the bottom squared will go. Everybody knows this. So here we go. We're going to do low d high. So low just means write down the bottom part unchanged. So I've got my x squared. And then d high. So I'm taking the derivative of the top part, the derivative of the numerator. So the derivative of 4 is 0, so I write nothing. And now I'm doing the derivative of this. So it's going to be the product rule. I'm going to look at it as this yellow factor times the blue factor. So that's what I'm doing right now. So the derivative of negative 2x is negative 2. And then I leave the blue part alone. And I put a plus. And then the second time through, I leave the yellow part alone. So I'm just going to put negative 2x. And I take the derivative of the blue part. So the derivative of y is dy dx. Okay, so I've done the product rule. So far I've done low d high. So now I need to go less high d low. So high means write down the numerator the way it is. So I'm just going to write 4 minus 2xy. So 4 minus 2xy. That's high. And then here comes d low, the derivative of the denominator. So that'll be 2x. Okay, so I've done low d high, less high d low. Draw the line, and down below, the bottom squared will go. The bottom squared will be x to the 4th power. Okay, so this is the second derivative, but we need it simply in terms of x and y. In other words, we're not allowed to have dy dx in here. This has to go. So ultimately, we are going to substitute dy dx with this entire expression, because we know dy dx is equal to all of this, so we're going to substitute this in. But I think it would be a good idea to simplify this as much as we can first. So let's see. Second derivative equals. I'm going to go ahead and do the distributive property here. So I'm going to have negative 2x squared y, and then minus 2x to the 3rd power dy dx. Okay, I distributed the x squared. This 2x, it will make me feel better if I put the 2x in the front. Okay, so I didn't change anything. But now it's easier for me to think of this as distributing a negative 2x. So I'm going to have negative 8x plus 4x squared y all over x to the 4th power. I'm noticing that we do have like terms here and here. So I'm going to go ahead and combine those and make 2x squared y. So now we have this. On my next step, I'm going to divide every term by x to the 4th power. So I'm doing this. I think I'll just go ahead and do this in real time. So I have the second derivative is equal to 2y over x squared minus 2 over x dy dx minus 8 over x to the third power. So now it's time to do that substitution I was mentioning. I'm going to replace dy dx with this fraction. So bam, I replaced dy dx with this fraction. Now I'm going to multiply the 2 and distribute through the numerator, and I'm going to multiply x times x squared and get x to the third power. So now we have this. To simplify further, we really need like denominators. So 2 of the fractions have x to the third power in the denominator, so I'm just going to multiply by x over x right here. So now we have like denominators. So let's combine this all into one fraction. Maybe I'll do this step in real time. So I have second derivative Okay, big fraction. So in the denominator, I have my x to the third power. So here's my 2xy from the first term. This minus sign, I have to distribute this. So notice how this minus 4xy is going to become a plus. So avoid that common mistake and make sure you distribute the negative sign. So I will have plus 4xy and then minus 8. So I'm noticing that we have like terms here and here. So that's going to make 6xy. So that's going to make 6xy right here. But then we also have negative 8 and negative 8. So I have minus 16. And I think that's the best we can do. So not a ton of calculus going on, but so much algebra. Let's try another one. So first, here's a little product rule. So the derivative of x is just 1, which I really didn't need to write. And I'm leaving the second factor alone, and I put a plus. Now I'm leaving the first factor alone, and I'm taking the derivative of the second factor. But the derivative of y is dy dx. The derivative of negative 1 is 0, so that's gone. The derivative of 2x is 2. The derivative of y squared, well, I've now taken the derivative of the outer function, but because this is a y and not an x, I need to keep going and take the derivative of the inner function. So I'm going to multiply by dy dx. So let's get all of the dy dx terms on the left side of the equation and put everything else on the right side of the equation. Okay, so I'm going to have my x dy dx over here on the left. I'm going to move this over here now. So I'm going to have minus 2y dy dx. I've got the 2 that's already there, but I'm subtracting this y. So I'm moving this over to the other side. So I'm going to have minus y. Because I have dy dx in both of these terms, I can factor the dy dx outside of parentheses because it is a GCF. So that will leave x minus 2y inside the parentheses. Now I can divide both sides by the parentheses to get dy dx by itself. And that will be 2 minus y over x minus 2y. So that's done. Now we need to take the derivative again. So we will now have the second derivative equals. Time for the quotient rule. So that's low d high less high d low. Draw the line and down below, the bottom squared will go. What was that again? Low d high. So low means write down the denominator. So here's low. D high means take the derivative of the numerator. The derivative of 2 is 0, so that's gone. The derivative of negative y, well, there's the negative sign. The derivative of y is just dy dx. So that's low d high less high d low. So high means just write down the numerator, which is 2 minus y. And then d low, derivative of the denominator. The derivative of x is 1. And here's my minus 2. But then the derivative of y is dy dx. So that'll be dy dx. So this is low d high less high d low. Draw the line. Down below, the bottom squared will go. So I have x minus 2y squared. So this is the second derivative. Somehow I need to replace these dy dx's by this whole thing. If there's anything I can simplify first, I better do that. I decided there wasn't much I could do in terms of simplifying, so I went ahead and did the substitution. So anywhere I had the dy dx, I have now replaced that with 2 minus y over x minus 2y. I did do one other tiny thing. This little negative sign that was in front of the dy dx, I went ahead and put that in the front. Notice that we have this denominator of x minus 2y, and this x minus 2y is in the numerator. So these two will cancel each other out. So that's all I'm going to do on this next step. So here's what it looks like after I cancel out the x minus 2y part. I am anxious to get rid of some of these fractions inside of fractions. So how do you get rid of a fraction? You multiply by the denominator. In the numerator here, I have this one fraction, and this is the denominator of that fraction. So if I could multiply by this, I could cancel that out and sort of flatten this down to one line, which I would love to do. So that's why I'm going to multiply the numerator by x minus 2y. Of course, I can't just do that. That would just change the value of the whole problem. It's only valid if I multiply the denominator by the exact same thing. Because now I'm just multiplying by 1, and that's okay. But I am going to have to do the distributive property. So here's what's about to happen. I'm going to multiply this x minus 2y. First of all, I'm going to multiply it here and here. Okay, so that'll take care of this part of the equation. But then I also need to multiply it by this term way over there. So this x minus 2y is going to show up in 3 different places. All right, see if you can follow this. So I multiplied my x minus 2y by this factor, this term way out in the front, and I just wrote it side by side. When I multiply by this whole term, when you have a product like this, you don't multiply by both factors. So obviously I was targeting the x minus 2y in the denominator, so I chose this factor to multiply by. But I had to distribute because it had a minus sign in the middle of it. So x minus 2y times 1 gave me this x minus 2y that you see here. But when I multiplied x minus 2y times this part, the x minus 2y canceled out the blue x minus 2y, just leaving the numerator of 2 minus y. Meanwhile, in the denominator, right here, this is already x minus 2y squared. So if I multiply by another x minus 2y, it becomes x minus 2y to the third power. Okay, so hopefully you can follow how I got all of this. So I'm noticing that we have a common factor of 2 minus y here and here. So I'm going to take this 2 minus y and I'm going to factor it outside of parentheses. So I'm going to take this 2 minus y as a GCF and put it out in the front. So as you can see, I pulled out the 2 minus y, and here it is in the front. And that left behind all of this. I did do one tiny thing in this area right here. I took the negative 2 and I went ahead and distributed that. So that's why I have negative 4 plus 2y right here. So I think what I'm going to do now is combine like terms and stuff. So notice that we have minus 2y and plus 2y. Those cancel each other out completely. That's going to leave me with x minus 4. Except then I'm going to distribute the minus sign. So on the next step, you're going to see minus x plus 4. And I'll distribute this minus sign as well. So here I did all that stuff I said I was going to do. And now I'm just going to combine a few more like terms. So I still have this 2 minus y in the front. But let's see. We've got the constant of 4. And then we have, let's see, I'm going to go ahead and put my 2y next. And then we have minus x, so that's minus 2x. And that is about as much as we can do. So kabam! There's your second derivative. Before I end this video, I want to be clear about one thing. Remember way back, okay, I'm scrolling way back to this step when we first substituted for dy dx and we got this expression right here. Technically, this was an acceptable answer. So if you were doing a free response question, the minute you substituted 2 minus y over x minus 2y for the dy dx's, you could have stopped and put this expression for your answer. And in fact, if this were a free response question, I would actually recommend that you stop right here. Because if this is correct, but yet you made a mistake in all of this crazy algebra, you would lose the point. So it's safer actually just to stop unless you need to keep going. The only reason why you would need to do what I did would be if it was a multiple choice question and you were trying to match up your answer with one of the options. In which case this, what I have in the box, I promise you this would not be one of the multiple choice options. Instead, it would look like this.